morning, 4th grade. Happy Monday. I hope you guys had a great spring break, and I'm excited to start this week off with some time. So we're going to be doing something called time conversions. So this is the video lesson you're watching. After the video lesson and throughout the video lessons, slides 4, 5, and 6 have guided practice on it and independent practice. So we're going to go ahead and get started talking about time conversions, what that is, what that means, all about time. So time can be measured in many different units. So units you probably learned about in 2nd and 3rd grade were hours, minutes, and seconds. So we're going to take a quick second to review what an analog clock looks like, which is this. It's a clock that has minute and hour hands. So as a reminder, the minute hand is the longer hand. This will tell us the minutes, and the way we tell that is by, for example, the blue around the clock. So I'm counting by 5, so I have 0, 5, 10, 15, 20. So for example, 3 times 5 is 15, so I know if that minute hand was pointing to the 15, it would be 3:15. So we're counting by 5. So here I can see that the minute hand right now is pointing to that double 0. Next we have our hour hand, and our hour hand is the shortest hand. We simply use, I highlighted it in yellow, and we count by 1, so we simply just use the big hour number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we go around the clock in a full day twice. So AM would be 12 hours, and then PM will be 12 hours. So on this clock, it's showing 3 o'clock because my hour hand is pointing to the 3, it's that shorter hand, and then my minute hand is pointing to the 12, which we represent with double 0 because that's where we start at. Now we're going to talk about an analog clock versus a digital clock. Many of you probably have digital clocks in your houses. I have one in my room. I know I use it as my alarm clock, but I know that some of you may have a microwave that shows a digital clock. Anyway, an analog clock is like one that we have in our classroom. It's right by our door, and then we have the schedule next to it. So in this instance, it has the hour hand, which is the shortest hand, and the minute hand, which is the longer hand. Again, we count by 5s. We start at the 12, and we count that as double 0, and then we have 5, 10, 15, and so on. So my hour hand was pointing to the 6, and my minute hand is pointing to the 11, so I represent that with 55. With a digital clock, it's a numerical value, so I'm still showing my hours and minutes, but I'm showing that digitally. Now we're going to practice converting time. So I want to see if you can drag and drop these digital clocks and match them with their analog clocks. So go ahead and pause the video and try. I'm going to start by looking at the hour hand of each of these clocks. So I'm going to be looking at the shortest hand to see what it is pointing to, what hour hand. So for this, we're going to be looking at the big numbers, so 1 through 12 around the clock. I'm zooming into the second clock to show you that it's not quite pointing to the 5, and since it's not right on the 5 or past the 5, I'm going to say that it's 4 something. So we're going to say 4 o'clock, something around 4 o'clock, but here you can see that the arrow is not quite at 6. It's in between 5 and 6, and since it's between 5 and 6, we're going to count it as 5 something. So we're going to look at the minute hand to determine the minutes. So I'm going to represent with this hour the 5. Now I'm going back through and I'm looking at the minute hand, which is my longest hand. When I look at the first one, it is pointing to that 1, and so I'm not going to put that it's 5:01. Since it's pointing to the 1, that represents 5:05 because I'm counting by 5s. The second one is pointing to the 11, so I can go around and label my clock by 5s, or I could do 11 times 5, which is 55. So I know that this time that represented on this clock is 4:55. Same thing for my last clock. Since it's pointing to the 11, I know that 11 is equivalent to 55 minutes. So I have 5:55. Just like with our previous measurement task with cups and ounces and pounds and etc., we don't need to necessarily memorize these conversions, even though they're something that you either probably have memorized already or something that you've are very familiar with. So, for example, there are 24 hours in a day, there are 60 minutes in an hour, 3,600 seconds in an hour, and so on. So I'm trying to figure out 2 days, how many hours is in that 2 days. I can use an input-output chart with my function machine if I want to. If I know that there are 24 hours in one day, how many hours are going to be in 2 days? I could either multiply 24 times 2, or I can use repeated addition, which is what I used here. I did 24 plus 24 and got 48. So I know there are 48 hours in 2 days. These charts should look familiar to you. They are input-output tables, but this time we're going to use the measurement of time. So my first chart, I can see that my 2 units I'm using are minutes and hours. So I'm going from minutes to hours, so I need to determine if I have 60 minutes, how many hours do I have? This might be something that you already know, but if not, you can look at your chart in the previous slide, and I can see that 60 minutes is equivalent to 1 hour. So then I need to go through and I need to fill in the rest of the chart. So I want you to try to fill in the rest of the chart. If I have 2 hours, how many minutes is it? You could have solved this first input-output table in several ways. So you could have done 60 times 2 or 60 plus 60, which is just repeated addition. Because I know that 1 hour is 60 minutes, so I know 2 hours, I'd have to do 60 minutes twice. So I know that 60 times 2 is 120 because I know 6 times 2 is 12. And then the same thing for 180 minutes. You could have done 2 options. You could have done 180 divided by 60. And then you could have seen the known fact 18 divided by 6, which is 3. So I know that there are 180 minutes, there are 3 hours. They're equivalent. They have the same value. You could have also done repeated addition, so 60 plus 60 plus 60, and you would have seen that that was equivalent to 180. And I have 3 60 chunks because I know that 60 minutes is an hour, so I have 1 hour, 2 hours, 3 hours. I want you to go ahead and do number 4, so 4 hours is how many minutes, and then try to figure out how many minutes are in 6 hours and 12 hours. So this is going to be independent practice, something I want you to do on your own, and then we're going to move on to the second input-output table of hours and days. So I can see that my 2 units here are hours and days. So I'm going from hours to days, so I have to figure out how many hours is in 1 day. So you may know this off the top of your head, or you can scroll back up to your time conversion table, and I can see that 24 hours is equivalent to 1 day. That's part of the guided practice we did earlier. So if I have 24 hours, that's equivalent to 1 day. They're the same value. So if I have 48 hours, I have to figure out how many days that is. So I remember from when we did guided practice earlier that I think it's 2 days. So I could have done 24 times 2 or 24 plus 24 and gotten 48. Or you could have done 48 divided by 24. So I can see that 48 hours is equivalent to 2 days. Go ahead and pause the video and try number 3 on your own. So if you have 3 days, how many hours is that? Alright, so you could have done several things again. You could have done 3 times 24 because 24 hours are in a day, but you have 3 days. Or you could have done 24 plus 24 plus 24. And so I know that 24 times 3, I can use the area model to help me solve that. So that's what I'm doing here is area model. So I put 24 into expanded form by doing 20 plus 4. So I know 3 times 20 is 60, and then 3 times 4 is 12, and when I add those together, my partial products, I get 72. So I know that 3 days is equivalent to 72 hours. So finally, I want you to do 4 days on your own, how many hours are in 4 days, and then try to figure out how many hours are in 7 days and 10 days. So all you'll have to do for these is 4 times 24, because there are 24 hours in a day, but I have 4 days. You could do 24 times 7 and 24 times 10. So I would use area model to solve these. Make sure you hit submit on It's Learning when you're done, and I hope you guys have a great day.